Hello everyone. Let's spend some time reviewing a bit about drawing cyclohexane and thinking about the chair-chair interconversion. You'll see I don't have my molecular models with me. I'm going to do it on the board, but you should work through this video with your molecular models close at hand so that you can see the correspondence between what we're drawing and what the model of chair cyclohexane actually looks like. So the first thing you should do is you should pause the video and you should draw your best cyclohexane in the chair arrangement. So feel free to put your cyclohexane model in the chair arrangement. Remember that you'll often see cyclohexane represented in this way. There are 12 hydrogens going around the ring. I won't fill them in. But we know that cyclohexane's energy minimum arrangement is not a flat planar one. It's a so-called chair. So can you draw that? Again, to review some of the tips, the drawing tips that we went over in class, one of the keys in drawing the cyclohexane chair is to keep the bonds that are opposite to each other in the chair structure parallel. So if you start with two parallel lines that are a little bit offset like these are, and then you go from there and you draw two new parallel lines like that, and then finally there are two more bonds that we haven't shown here. I don't know, some of these colors don't show up very well on this particular blackboard, but this line then should be more or less parallel to that line. Okay, so there is the cyclohexane chair type of drawing. Again, opposite sides are parallel. It's key to a good drawing that you have this kind of offset of the lines, and then you have parallel, 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 parallel. And it shouldn't look like a bow tie. It should really look more like the model would. Okay, so you want to look at this from the right perspective. Okay, so hopefully you were able to draw the cyclohexane chair, and this is something you just need to practice and practice and practice. So wherever you are, if you're out for coffee and you're sitting there in the coffee shop or wherever, and you've got your piece of paper or you've got your napkin and you've got a pen or a pencil, just draw cyclohexanes in the chair arrangement wherever you go. Okay, so the next part of this is to fill in the hydrogens. There are 12 of them, so we'll have to fill in 12. And let's start with the ones that I claim really are easier. Let's start with the axial ones, okay? And remember, they alternate axial down, axial up, axial down, axial up as you go around the six-membered ring. So again, pause the video, fill in the axial hydrogens. Start at a corner. Here we go. Does this corner point in the general direction up, or does it point in the general direction down? Well, it's pointing up. So the axial hydrogen, let's see, I'll put my axial hydrogens just in white chalk. That axial hydrogen will go up. So once you do that, then you just go around the ring, alternating axial up, axial down, axial up, and then use this little artistic device here, leave a little gap in the bond that's in the back just to keep track of what's behind and what's in front. Axial down, axial up at this carbon, and then axial down, this bond goes behind this pink bond that's in the front. So hopefully that's 1, 2, 3, 4, 5, 6 axial hydrogens. Have you built a model of this? If you take your model that you think is in the chair arrangement, remember if you just take that model and you put it down on a flat surface like the table, it should just very nicely sit on this tripod of 3 axial down hydrogens. If it doesn't seem to be sitting like that, you probably have some problem with the shape of the ring. It's not really in a chair. So those are the axial ones. There are 6 of them. The other 6 are kind of around the equator of the ring. So remember, they're called the equatorial hydrogens. So can you fill in the 6 equatorial hydrogens, and let me just remind you of a couple guiding principles. So first of all, at each carbon, there's a group that's in the up direction, and there's a group that's in the down direction. Now, the down direction may not be as dramatic as this, axial down. It may be equatorial down like that, but at every carbon, you should check that if you have an up group, you also have a down group, okay? And then the other concept is that the equatorial bond, so I'll fill this one in for you, right? So there's an up hydrogen here. There should be an equatorial down hydrogen there. And so this bond right here, maybe I'll use a different color. How about I put the equatorial hydrogens in yellow. This equatorial bond is parallel to these 2 pink bonds. So I referred to those bonds as the carbon-carbon bonds of the ring once removed from where this is. So check that this is parallel to that, this is parallel to that. Okay? And do that as you go around the ring. Okay, so you pause the video and fill in the other 5 equatorial hydrogens in this molecule. Okay, let's work our way around here. So this carbon already has an axial down group. So the equatorial substituent will be up like that. So, sorry, this is supposed to be yellow like that. So you see how this bond is parallel to this bond and that bond. Here's one that sometimes gives people difficulty. Here's axial up. I need an equatorial down bond, and I need it to be parallel to this and to that, so it goes right there. And then axial down, equatorial up. This should be parallel to that. This should be parallel to that. This one, axial up, so I need an equatorial down bond there. And this one should be parallel to the orange bonds there and there. And finally, this one is probably the hardest one for people to do. So if you haven't filled that in again, give it a try. Well, this already has an axial down hydrogen, so it should be equatorial up. And it should be parallel to the bond once removed, that one or that one. So your drawing should have the 6th equatorial hydrogen there. Okay? So just to recap, draw the backbone of the cyclohexane ring. Be sure that the opposite bonds are parallel when you do that. Once you're satisfied with that, I recommend filling in the axial hydrogens, alternating axial up, axial down, axial up, etc. around the ring. And then the last thing you would do would be to fill in the equatorial substituents, being sure that each carbon has an up group and a down group, and being sure that the equatorial bonds are parallel to the ring carbon-carbon bond that's once removed. Okay? So do that 10 times, and I think you'll be well on your way to being a good cyclohexane chair drawer.